we've already talked about this, but specifically we're going to look at an activity where we discover how these parameters affect how AH and K affect our graph. Okay, what I want you to do at your table is we're going to do what's called a KWL. You're going to look at what you know about this function. Okay, that's number one. I want you guys to talk about what you know about this function, what the parameters do. Okay, in the middle, what would you like to know? And finally, now at the end, we'll look at what did you learn.
Are we actually writing this and discussing it?
You can discuss it if you want to write them because we're going to share. Now, hopefully at the end of the lesson, you're not saying, well, this entire thing's blank. I didn't learn anything. Okay? Now, the computer's going to be off, so we're going to take 5 minutes as I get attendance done. And I want you to talk about what you know, what you would like to know, and then the last column I'll see at the end when we come back together what you did learn. Okay? So go ahead and do that. Talk amongst yourself. I'm going to get attendance stuff done. Good afternoon.
Hey.
Hey, do you want to get on camera?
No, I don't.
Okay. You're on camera.
Did you put 8 computers yet?
We did. We've got, I think we got 8. Yes.
From
1, 2.
From Harrison, he wrote them down.
Harrison, how many did Harrison bring down? Just 4? Because Matt Smollett had the other 4.
Yeah,
Yeah.
he wrote them down.
Okay, he's also grabbing your the lab itself.
Well, that's nice of you. Thank you.
Do you need that? Or?
Yeah, that'd be great.
Okay.
Thank you so much. Okay, so I'll go ahead and do attendance. Go ahead and talk amongst yourselves. That's fine.
Wait, Mr. Ben.
Yes.
Can I see myself in polynomial equation notes?
No, not yet.
A determinant.
H and K.
Yeah.
Taking it to the
H determines the graph if it's right or left, and K determines if it's up or down.
You said K does what?
H moves the graph left and right, and K moves it up.
Yeah.
What happens if K is positive?
No, it goes to the right.
If K is positive?
No, it goes up.
Oh,
It goes up, right.
I was thinking
And the vertex is HK. And H is positive.
It isn't actually. Whenever there's a minus, it's not negative. It's just H. It's the obvious. You always want to get it into the x minus H.
Yeah, we're
After vertex form, then you have to label all the...
Alright,
So we started talking. What's going on? What do we know about? What do we know about A?
What would we like to know?
Oh, we didn't get specific. We also need to know how...
Vertex form. So what does it tell you?
yeah. Oh, that's fine.
Well, it's all right. It'll be better if it's up.
So we know it's vertex form. A represents, it's not the slope, but the
Try not looking at your nose. Except we'll do this before you can.
yeah, that's fine. Well, give me a little.
You know what H and K are?
H and K are the vertex form.
Vertex. Okay. So what does H do?
H is
Think
shifts.
about it.
I know H and K both shift, but H shifts to the left. Shifts.
So
to the
what
left
value
and
does
right.
H have to be to shift left?
If it wants to shift left, H has to be negative. If it wants to shift right, it has to be positive.
Okay.
And X is.
What does that do to the sign of the function?
What it does inside of the function or
With H?
with H, it changes possible solutions.
The more think of operations.
Oh,
You're right with your H value, but I want you to think about that. So what do we got? What do you think?
We know that H will be the axis of symmetry.
Okay.
I have them in my bag.
Oh, okay, so when you see that subtraction sign, what do you know?
Alright.
It's opposite, so if you see x minus 3, what's going on there? So which direction would you move?
What else?
To the right.
To the right 3, even though the operation
It
is...
says negative.
Max.
Very good.
Thanks.
Yeah.
Thank you. As you guys are discussing, hopefully you're not missing plugins. If you are, then we could have an issue. On a side note, really quickly, their website is GeoGebra, dc.wikispaces.com, and you're looking for parabolas in vertex form. It will take a couple minutes to load, so if you click on it, it doesn't open. Click on it again, it doesn't open. Let it go. The website can be slow. For those who don't have computers, we have it up and running here, and we also have it up and running over here as well.
Wait.
Oh, you have a Mac? You can, well, go to Gmail and you can open Gmail, but I can send it to you.
Mr. Bennett, can we grab?
So what do you guys want to know about this function? I've heard a lot of what we do already know, but what do you think you'd like to learn? Okay, so how it fits in quadratic form, so you mean in standard form? Okay, okay, that's a good question. How would we get that to look like standard form? Does every vertex form, can every vertex form be in standard form? I think so. All right, well, that's interesting. Okay. Let's share. Let's come together. Let's share some of the things we had. And now, as I said, for you guys, this is a little bit of review, but hopefully you're going to see this in a different light. Okay, GeoGebra is a dynamic math software that I've done a lot of work with, and so it's going to be interactive for you guys to work on, and we'll see what we can do. You may have to share, especially if the computers are not working. We'll get there. Does anybody want to come up and share or write down some of the things they know about this function or think they know? Shakira, Kenneth, come on up. There are other computers up here as well. Did you go to Gmail? Because if you look under the apps thing, what there should be one for, I don't know. So when you click on it, there should be one for GeoGebra, and I can upload it. I can email it to you if you want to. Okay, sorry. So I think it'll work that way because it's working. If anybody wants to use my iPad, just because I can, yeah.
So if it's negative, if it's down, positive,
Parabolas and vertex. Yes, you can. No, you can't have it. You may borrow it. All right, so we know that H and K.
It doesn't work on this.
It's not working on there?
This is the Java.
Yeah, me too.
Okay, I'll show you. All right, so H and K make up the vertex. Okay, H is the axis of symmetry. Now, what do we know about the axis of symmetry? What is it?
It's a vertical midpoint.
It's the y.
Okay, so vertical line. It's a midpoint. I like that because what do you know about points on the left and right of on the parabola?
They're symmetrical based on the axis of symmetry.
They're symmetrical, so they're the same distance away. So if you cut right down the middle, really from my pupil to this pupil should be the same distance, so it is midway through. That's a great point. All right, H means opposite. Okay. Negative H. So if you have a subtraction sign in here, x minus 5, which direction are you actually moving?
Right.
Right. It's opposite. Does that work for K as well? No. Okay, so anybody else want to contribute to what you would like to know? Yeah, that'll happen with technology. We can have a couple of you up here. We can have a couple of you over there. That's fine. Go ahead.
I want to know where your
Listen.
parabola meets the x-axis.
Okay, so you want to know,
The x-axis.
so where the parabola meets the x-axis. So is there like you mean something like a theorem or something where that you can just use and you know the intercepts?
I mean, if you plugged in the formula, where
That's okay. That's a great point. Where would the x-intercepts be? A lot of people would try to say, just say, let's plug in 0 for y, right? What does this look like to you? If I ignored the k, what have we talked about quadratics? What does that look like? What have we done before when we solved quadratics? Someone new. What does that look like?
It looks like when you're in the middle of factoring quadratic, when you have pulled out a common term and you have binomial left, and so when it's taken twice, then you know it's going to appear twice, or when it's taken twice.
Okay, so what would appear twice?
Now
Now you're getting ahead into polynomials, right?
Yeah.
What's the multiplicity there for a quadratic in vertex form?
It's 2.
2. Okay, so if the 0 was h, we'd be behaving like a quadratic at that 0, right? So you guys are a little ahead, and that's good. Another group said standard form. And I asked the question, will vertex form, can that always be written in standard form? What do you guys think? Can vertex form always be written in standard form?
Yeah.
I think yes.
Well,
Yes, absolutely. You just have to use, what would you have to do?
you have to graph it.
Not necessarily graph it.
what if you have to distribute and then like
Perfect.
change your variables?
Perfect, right. First you have to distribute. Now, the other thing I want to go back to, and I maybe lost standard form, the x-axis. When you said the binomials here, doesn't that look like completing the square?
Yeah.
Yeah. In this case, we have an a value. Does anybody want to say anything about a?
It determines whether the parabola opens up or down.
So a opens up or down. Right, based on its value. What else?
Oh yeah, it determines how narrow or wide it is. based
Narrow
on
or
how
wide,
great the
okay.
value is.
That's really good. So what you're going to do today, what we're going to study is, you're going to discover, and you guys know this already. Now obviously this is more of a algebra lesson, but you know, being as our schedule, nobody teaches. I can't go to see an algebra class because I teach during that time. So algebra 2 is the next best thing. It's better. You're going to discover how h and k affect the graph, and I hope from this diagram, this worksheet, that you learned something that you didn't know. Okay. Number 2, you're going to be able to write equations in vertex form. If I give you the a, h, and k and a point on the graph and say, write that equation, what does that look like? So that's a couple of things you're going to look at, but the main goal is to see and to use this. So when you get to that page, it may take a second. Some of the plugins are missing. Now here's what is going to happen. You're going to study each variable. So let's say 3 people's computer doesn't work and you're over there. One person, when you're doing the first variable, manipulate the sketch. After that variable is done, that parameter is done, switch. Allow someone else to use the sketch and someone else can write. But rotate that 3 times, okay? Does that make sense to you? If you have a computer that works, okay, how many people don't have a computer that works? Okay, hasn't been able to file. Someone should be at your table to share with. How many? Everybody's working over here?
Yes.
Someone can go work with Ken. You can sit together. The document that you need is on your table already. It's called Parabolas in Vertex Form. It says Open Parabolas GeoGebra. You're already on the website. You're there. Okay? Okay, then what do? Well, it's an investigation, so you need to read, and the steps are going to prompt you through. Where you see a Q2, Q1 in bold, those are questions you have to answer. But this is a kind of a self-discovery. If you follow these steps and answer these questions, it will walk you through what exactly to do. If you have questions, please raise your hand, and I will help you. That computer works if you want to go over there. It should. You guys didn't close that, right? Who was over there? You didn't close that out, right? The internet?
It's Internet Explorer.
Okay, yeah, you can open that up, and people can come up here if you want to pull up a chair. This is loaded on an older Mac, okay? We're going to check back in 20 minutes at 25 after. And we're going to start talking about this and see if you guys have learned anything, and we'll get to that last column. Okay? Questions before we go? So did you go to GeoGebra? GC got wiki spaces? GeoGebra, yeah, you got to go to GeoGebra DC. You missed the DC. And then on the left navigation bar, you'll find it.
So the plugin is needed to display this content.
Okay. Are you downloading it? Job and runtime.
It's downloading now.
You can manually do it, or you can roll it. Yep.
Did you open the right one? Oops. You went to
You were up on it, right? Oh. That's weird. What happened?
You need to go to that one right there.
There you go. Now it should load. Scroll down. It should load. Did that work?
This only has 26%.
All right. So, two up there. So you can go over to this side computer. This one's going to load. All right. Someone who can work with Nathan. Shakira, you're up front with Caroline. Okay. Okay, so that opened. It does take a minute to open. Okay, so be aware of that. I know we're used to super high-speed internet. You want to work with Nathan? Slide over and work with him. Yes, ma'am. So scroll down.
The battery or
Can you refresh?
mine is not so much. Well, it's loading.
Yeah, that should load. What does it say at the top? It's now
Are you
okay.
trying to download the newer plugin?
Okay, so why don't you guys come on over here? Why don't you two pair up? Rodrigo, why don't you guys work together? You two come on over here. It should be on the left side.
Wait, let me see.
Only has show standard form.
So it should, so like here, show standard form on the left side. So scroll down. Show standard form, show vertex. Which one are you missing?
It says show transform.
I refresh it.
That's not. It should be on there.
It's not on this one.
Oh, I'm sorry. Show it is not there. Why isn't it not there?
It's not loading.
Okay. That one's not loading. Okay. So, did you guys, where does yours, which one did you
This could be like a trial.
Show transform.
No, it might be. I'm not on.
Yeah, hold on one second.
I think maybe you have to be connected to.
No.
Your
I think I
thing.
switched it. Okay.
Oh,
So,
you have to adjust A.
no. So, here's the thing. I apologize. This is apparently, when it says show transform, you don't no longer need to do that. You can just adjust sliders A, B, and C, and that will show you. It'll start to manipulate the graph for you. Okay, when you move, does that make sense? Sliders A, B, and C on the left will automatically move your function.
I'm stuck at the GeoGebra loading screen.
Does it just like
Okay,
take
you
forever
guys
to
need
load?
chairs, don't you?
Oh, it works.
Did that load?
Yeah, finally.
Finally, it's not too bad.
Ooh.
Maybe Java's not up here.
No, it just takes really
Now,
long.
Andrew,
Oh,
is
so yours was
anybody
spinning
not,
for
is
all
yours not working? Come on over here.
Okay.
When A equals 0, it's just like flat. And then if it's negative, it's on the bottom. Positive
Hold on.
Happy birthday, Jeff.
So,
No, I didn't do anything. No, you're. Yeah, but you don't want to start redefining any of my the variables. So you should. So what happens to the function?
It would make sense because, like, it's easiest to narrow when, like after 1. Basically like when the A values
After 0.
it's like 0 to 1 and then like 1 and negative 1.
Yeah.
So whenever it says redefine,
I guess.
So that's what it's
When the A value is higher than 1 for it to narrow upward.
It narrows into negative. Right.
Okay, so the parabola ceases to narrow when the A value is higher than 0.
You very well could have
Well, no, higher than 1.
Because it narrows up, and it also narrows down.
I know, okay. So I'm trying to figure out how to word this because it ceases to narrow upward when the A value is higher than 1. It ceases to narrow downward when the A value is less than negative 1. Yes, it switches because negative 2 is lower than. Yeah. Okay, so when.
How about does the parabola cease to narrow for all A values? Or does the parabola cease to narrow?
Cease to narrow. My desk is like an Apple store.
It is. It feels like it, right? This is the great thing about technology, though. It works sometimes and it doesn't, depending on what. Okay, so here's our function. Let's try just to grab it. There it is. Okay, so this is a different.
So the parent function is the one that's.
So the one in blue is not moving. That is x squared. That's correct.
So the brown one shows 100.
So the red one is the manipulated. Okay, and so try to use the stylus. That might be the easiest thing for you to do. Okay. Yes. What's that? No, that's fine. So you can either plug in specific values, or you can. So it's just one function. I just made them different colors so you can see the difference.
What
No,
type
so
of
it's not like
transformation does changing A represent?
It makes it like
Widens or narrows?
Oh no! Don't start a sentence with it. It affects. What affects? It affects the. Okay, so we're good.
Does not
Ladies, how we doing over there?
A equals to 0.
Oh.
What happens?
So, great question. So does the A value, all values of A make the function narrow? Will the function always narrow?
No.
Can someone tell me what value we don't want A ever to be? 0. What happens to a quadratic when A is 0? It's a flat line because what have you eliminated? Which part of the, which term? X, the x squared term. If you have an x squared term that's 0, what happens to your function? It becomes
0.
Well, it's flat line. It becomes linear. If you have a quadratic and you eliminate the quadratic part, the only thing left is linear, right? Whether if it's ax plus a number or a constant. Be careful, okay? So when does it cease to narrow? 0, but what else? So show me. Well, yeah, but I capped that. So when do we widen? When does A widen? Does it ever get wider? Right? So, okay, wait, slow down a little bit. So why don't you go to A? You see the input boxes on the right? Why don't you input 1?
Question 2.
Okay, so that's standard, right? A1. Now go to 0.5. A equals 0.5. Half.
Ceases.
Did that widen or narrow your parabola? Widen. So do all values of A widen the parabola? Make it more narrow. I'm sorry, make it more narrow. No. What values do you think that the parabola won't narrow? Values of A. Not whole numbers. Half. 3/4.
Oh, you mean which was wide in it?
Yeah.
Yeah.
So numbers that are less than what number? Fractions are less than. Proper fractions are always less than 1. So values that are less than 1. But is it just? What happens if we do A is negative 1/2?
Doesn't it face down?
Okay, it faces down, but will the parabola narrow or widen? Okay. So is it just values of A that are between 0 and 1? What would you have? Okay, -1 and. But we want to look at not just that. the
Oh my God.
absolute value.
I don't know what that is.
Kenneth, how you guys doing over here?
I just reinstalled Java, so it might be working. I haven't tried yet.
It hasn't, I thought you said it, okay.
I had it already, but I had to reinstall it because it was being used. So we're out losing versions.
It's a fraction of it. Or not narrow.
Right, it's fractions, but you got to be careful. Ladies and gentlemen,
Okay, it's good.
what values of A make the parabola widen?
Greater values.
Listen.
Lesser values, I'm sorry.
Okay, so what do you expand lesser values? What do you mean?
As
Okay.
as the value of A goes down before it hits 0, it's going to get wider and wider.
So fractions. So be very careful when you say fractions because 10/5 is a fraction. But if A was 10/5, what is A actually?
2.
2. So will the graph narrow or widen?
Widen.
No, it wouldn't. If A is 2? So don't just say fractions. Because when A is a fraction, yes, it should widen, but it has to be between what numbers?
1 and 0.
Yeah, the absolute value has to be between
1 and 0.
1 and 0 because it works the same when the parabola opens down.
It's
Yes.
still going to widen if it goes from 4 to 3 or 3 to 2 as well.
Right, because your A value is getting smaller, so the function's not growing as fast. That's correct. Sorry. Is that working better for you?
Yeah, I know, it's fine.
Okay.
That's me the 2 minutes.
Reflected symmetry, the parabola flex over the other side.
A to be negative.
What kind of symmetry do all parabolas? Okay, so think of ax squared. What line is that on? Where's the axis of symmetry? Ax squared. So show the axis of symmetry. Here it is.
That's what we did. I
Okay.
don't understand what the question was asking.
So for if it's just ax squared, so meaning if h is 0 and k is 0, what is the axis of symmetry always going to be? 0. So what is what kind of symmetry do we have there? You're right, it reflects over the y-axis, so we call that what type of symmetry? No, well, it's y-axis symmetry.
Oh, wow.
No, you were close. The parabola reflects over the y-axis, so it gives it y-axis symmetry. About 10 minutes. I can wave to my teacher, it's fine. You can even be funny just going because you watch. So you just look.
We're done.
Oh, we're done?
It's 26.
What's 26?
I've done 26 minutes.
Oh,
Do you want
Okay.
to bring the whole thing to a conclusion?
yeah, we will in 10 minutes, so I think we
Sorry.
can.
Mr. Bennett, I have a question. So, all parabolas of y equals ax squared, they're all symmetric, over the axis of symmetry, right? That's what that's asking.
Okay, so where would the axis of symmetry be?
Wherever the h value is?
So what's the h value when you
0.
just? Yeah. So, well, look at your axis of symmetry now. Where is it located now?
0.
Okay, so you're reflecting over which axis?
The y.
The y-axis. Yes.
So they have that.
As well as. It doesn't sound that high. The bigger the number, the skinnier. Told you that. The bigger the number.
Wider A to be negative. What a fact weird.
I know, that's why. Okay.
What? The bigger the number, what for a? Right. The parabola gets more narrow because what's happening to the y values?
The y values?
When a graph gets more narrow, what's happening to the y values?
They're increasing.
Yeah, they're getting larger faster.
I don't understand. Okay, so adjust H.
What's your question?
We can't figure out
I don't
what
like cameras. Put it on someone else's face.
It's not on you. So okay. So what have you found with A does?
Whenever it's
It changes like the direction of the parabola and how
Okay. So when A is negative, what happens to the parabola?
it goes down.
it goes.
Opens down. Okay. What happens when A is very large? What happens to your parabola?
Narrows down.
gets, okay, so those are some of the things that you're summarizing there. That's perfect. That's it.
What'd you say? A, what's the direction? Controls the direction.
Ezra, how are you back there?
I'm good.
Okay.
Make it like it closes on the Y intersection.
Y. What do various graphs of y equals x squared if a equals 0? Are the graphs still a parabola?
No. What do you
What do they become?
A line.
Yeah, they become linear.
And what else did we say?
A controls the direction and width of the parabola as it opens or closes down.
Okay, and adjust it left to right, and then K, adjust it.
Up and down.
So what is it? If h moves, the parabola moves left or right. How many units?
One. Like one.
Well, whatever
Alright.
h is, right?
Yeah.
All right.
Adjust the sliders for H and K.
Gentlemen, that's okay. Some of you didn't get through all of this. Obviously, this is, as an Algebra 1 class, we'd probably spend a day doing this and then really kind of summarize what's going on. But I want to bring a couple things to attention that I think you guys got out of this. Number one, did you like using GeoGebra? Was it pretty interactive?
Yeah.
Pretty straightforward.
I like
Maybe we'll have to turn off the camera. No, this is, I got into this a long time ago, and it's a really great software. I was sitting for a conference, and this lady said GeoGebra, and it was a calculus thing. I'm like, what is GeoGebra? And I started messing around with it because it was a really nice alternative to Sketchpad. All right, so does anybody want to volunteer to hit the button? Oh, you're quick. Come on up. Come on. Show vertex. Show vertex. Show vertex. Show. Well, I don't think it'll. I wanted to actually have it where we could use this. Oh, there. Now it works. All right, so let's go back. Because it wasn't working. I wanted you to interact with it, but apparently it doesn't work. All right, let's go back to this. And I want to know, what is one thing you guys learned? There's a few things I found as I went around. One thing you guys learned. Go ahead. Okay, so we learned, what did we learn? When a equals 0, the function f of x is linear. Now whether that's a horizontal line if there's no bx term, okay, what else did we learn?
And then the closer to 0 the absolute value of A is, the more the graph will widen.
Okay, so as the absolute value of A is greater than 0 but less than 1, the function now I wanted to start with what we learned because I think that's the most important thing. This is review for you guys, but I want to know what you learned because that's like, oh, I didn't know that before. Anything else? Yes, Grace.
Functions of H and K in the equation.
So you learned, okay, so you learned what, so H does what?
H moves the parabola left or right, and then K moves the parabola down.
Left to right, K moves up and down. And I'll have to get out of the way here, sorry. With the computer cards and all this stuff. Okay. Well, that worked, didn't it? Now, for some reason, this is... Yeah, can't undo that because for some reason it's like squishing the letters now, and I don't know why it's not supposed to do that. What else did we learn? There's one other thing, Kenneth, that I saw. What else did we learn?
A as a negative causes the parabola to be negative.
Okay, so you mean the parabola opens down. When A is negative, the parabola opens down. Good. What else? There's one more thing, and I think it was question 3. Security, you want to help me out here?
When the parabola is y equals x squared, there is y-axis symmetry, and that's.
I'm sorry. Say that again.
When the parabola is y equals x squared.
So y equals ax squared.
I mean ax squared. Sorry. the parabola. The parabola has y-axis.
Y-axis symmetry. Now, will that happen if the h and k value change?
Yeah.
Especially with the h value. Will you still be symmetric to the y-axis?
Oh,
No. That's very good. So yeah, when you just have ax squared, that's another thing. It has y-axis symmetry. Meaning, when you reflect over the y-axis, it's the same distance. You said midpoint earlier, right? Yeah, the midpoint would be that axis of symmetry. That's very important when h changes. What happens if k changes? Just k, not h. Would you still have y-axis symmetry?
yes.
Yeah.
You would- No, that's okay if you say no. It's like, well, no. Great. So that's when, I have no idea what I just did. So if I bring up my graph, and I just move k up,
Oh, yeah, no.
do we still have y-axis symmetry?
Yeah.
Now, the other thing I want to ask you is if I just change k, does that make my parabola wider? Because if I bring it up, doesn't that look like it's getting more narrow?
No, it's just going up.
Right, so if I take this remote and think about the elevator, right, if I just go up the elevator with it, and if you have a certain screen that you can see, right, all of a sudden you don't see that remote and you go here and you're like, oh, look, I can see the whole remote, and then all of a sudden you don't see all of it. Is it changing the width? No, you're just moving it up and down. Okay, that's the idea, but that's great. That's something people do observe when they start missing some of that parabola. Maybe you only see this part and you think it does narrow and it doesn't. Okay, Jordan, anything else? No. Love it. Else? It's the Michigan talking. All right. Anything else that you learned? I think we did a pretty good job of what we knew. H and K make up the vertex. Okay. What happens if H is positive? What happens with the operation inside there? Will that be positive as well? So I changed H, and you can see that H in this case, it's hard to see, is 5. My parabola shifted 5 units right, because what is the actual value of H?
Negative.
No, the actual value of H is not negative if the value moves right, it's 5. But take away 5. Think about it. If you had a $5 bill on your table, and I took it, is that $5 negative? No, but the operation I did is I took that from you. So I'm taking away a number. And that's a big difference between an operation and a sign. A sign on a number, -5, says, hey, move 5 units left, okay, of 0. If you have take away 5, you're actually taking away a positive result. That's why H is positive. Now, when I swing left, H should be what value? Negative. And what happens to that sign? Notice, look here. Yeah, because you're subtracting off what number? A -2. A negative number. When you subtract a negative, you become positive. But you guys did a nice job, and you didn't know this prior, okay, but this is just a nice activity we have. We have A opens up or down, we got that, the absolute value. I think that's everything that I wanted you to get out of that lesson, okay? If you have any questions, please see me about it. You guys can, we have about 10 minutes to wrap up, and so you can continue on what you're doing and answer those questions instead. Oh, that was